Hi everyone, welcome to the third lesson on recurrence relations. Today we're going to look at finding a formula from a sequence. So what we can be asked is to work out a recurrence relation if we are given the terms in a sequence. So basically we're working backwards from what we've done up until this point. So if you're given three terms, you can find the formula for a recurrence relation. It involves the use of simultaneous equations. So we'll have a look at this example here. It says the first three terms of a linear recurrence relation are 5, 15 and 35. Find the formula for the recurrence relation. The first thing I'm going to do is just assign names to each of these terms. So we'll say that u0 is 5, u1 is 15 and u2 is 35. And this just helps us form simultaneous equations using the general form of a linear recurrence relation. So a linear recurrence relation, we know, is given by un plus 1 equals aun plus b. So we're going to plug in what we know so far. So I know that u1 will have come from a times u0 plus b. Now I know that u1 is 15, so I'll put 15 here, and I know that u0 is 5, so I'm going to have a times 5, which I will rewrite as 5a plus b, and that gives me an equation there. I'm going to repeat the process, but now for u2. So u2 will have come from a times u1 plus b. Now I know that u2 is 35. So 35 equals a times u1. Well, u1 is 15, so it's a times 15, which I'm going to rewrite as 15a plus b. What we've got here are two equations that we're going to solve simultaneously. So I'm just going to put some dots to separate out part of my page. So I've got one equation, 15 is equal to 5a plus b. And I'm going to label that as equation 1. I've got another equation, 35 is equal to 15a plus b, and I'll label that as equation 2. Now I want to be able to eliminate one of the variables here, so I'm going to subtract, and I'm going to do equation 2 take away equation 1. So this is just straight from that 5 at this point. So 2 take away 1 would leave us with 20 is equal to 10a, and the b's would obviously disappear at this point. So 20 is equal to 10a, 10a is equal to 20, so a is 20 divided by 10, so a is 2. So we've worked out the value of a, and what we're going to do is substitute that value of a back into one of our equations, and we can get the value of b. So if we sub a equals 2 into equation 1, we end up with 15 equals 5a plus b, 15 equals 5 times 2 plus b, so 15 equals 10 plus b. If I subtract 10 from each side, I get 5 is equal to b, which I'm going to rewrite as b equals 5. So there we are, we've got our answer there. A is equal to 2 and b is equal to 5. We can now write down a recurrence relation. Un plus 1 is equal to 2 un plus 5. Okay, what I'm going to do is put another question on, and I would like you to pause the video and attempt this question. Hopefully you've now had a chance to attempt this question. I'm just going to run through it and you can check through your working. So the first three terms of a linear recurrence relation are 6, 7 and 8.5. Find a formula for the recurrence relation. Again, I'm going to start off by saying that u0 is 6, u1 is 7 and u2 is 8.5. This allows us to form simultaneous equations. Writing down our recurrence relation, un plus 1 equals aun plus b, I know that u1 will have come from a times u0 plus b. Now I'm going to substitute in u0 and u1 in here. So 7 will equal a times u0, so it's a times 6, which I'm going to rewrite as 6a plus b. And I've got one equation now. u2 will have come from a times u1 plus b. So u2 is 8.5, so I get 8.5 equals a times u1. So a times 7, which I'll rewrite as 7a plus b. And now I've got two equations which I can solve simultaneously. So 7 equals 6a plus b, we'll call that equation 1, and 8.5 equals 7a plus b. It's not very good looking b there, I'll change that. And that's equation 2. Again, I want to eliminate one of the variables, so I'm going to do equation 2 take away equation 1. So 8.5 take away 7 leaves me with 1.5. 7a take away 6a leaves me with 1a. And b take away b leaves me with nothing. So 1.5 equals a, or we'll rewrite that as a equals 1.5. Now what we're going to do with that is substitute it into one of our equations to find out the value of b. So let's sub a equals 1.5 into equation 1. So if I write out equation 1, which was 7 equals 6a plus b, so I get 7 equals 6 times 1.5 plus b, so 7 equals 9 plus b. If I subtract 9 from each side, I get negative 2 is equal to b, or b is equal to negative 2. So I'll just write them at the side. A was 1.5, b was equal to negative 2. Now I can use them to form my recurrence relation. So un plus 1 equals 1.5 un, and this time it's subtract 2.